Hi, in this video, we're going to talk about the fishbone diagram. First, we'll talk about what it is and what it is for. Then I'll show you how to make your own fishbone diagram and give some examples. And lastly, we'll discuss its advantages and disadvantages for you to know when and why you would use it. So what is a fishbone diagram? A fishbone diagram is one of the main tools used in root cause analysis for problem solving. It is a graphical illustration of breaking down all contributing causes to a certain effect or problem by sorting these factors into useful categories. With this, one can easily determine which issues have to be addressed in order to avoid a particular event. In the development of an analytical method, it shows the influence parameters or sources of uncertainty of the whole analytical procedure or of a single working step that would affect the outcome. The name fishbone diagram is based on a similar shape with the side view structure of a fish skeleton. The effect or main problem is shown as the head of the fish facing to the right, while the causes extend to the left as fishbones. The ribs branch off the backbone for major categories of the causes, with sub-branches for root causes, to as many levels as required. Unlike a flowchart which describes a chemical analysis as a linear structure in time, from acquiring the sample through the presentation of the results, a fishbone diagram shows a hierarchy of root causes leading to a specified effect. This is why it is also called a cause and effect diagram. In some cases, it is referred to as the herringbone diagram, based from the skeleton of the herring fish, or the Ishikawa diagram or Fishikawa, based on a Japanese professor named Kaoru Ishikawa, who popularized its use for quality management systems in the Kawasaki shipbuilding industry in the 1960s. So how do you make a fishbone diagram? It is a four-step process and making one is really simple. First, establish the problem. It should be clear and simply defined. We will write this inside the head of the fishbone, then draw an arrow from the tail leading into the head of the backbone. The problem should be SMART or specific, measurable, achievable, relevant, and time-bound. The next step is to define the categories of the causes. There are common models or frameworks for the categories that vary depending on the function of the diagram. The typical model is a 6M model used in manufacturing, which divides the causes into man, which factors manpower, labor, or personnel's knowledge, skills, and experience; materials, which includes the purity, storage, and labeling of reagents, raw materials, and such; methods, which describes the factors within the operating procedures; machine, or factors within the systems, tools, or equipment used in the procedure; measurements, like consistency in manual or automatic readings, data collection and calculation; and lastly, mother nature, or the environmental factors, which are mostly unpredictable and uncontrollable. For marketing, we have the 8P model, and for service industries, we have the 5S model. Note, however, that the categories may be unique depending on the application. For analytical procedures, in our case, a particular analytical result is dependent on many parameters, whether variable or constant, and contributory factors that affect the result. Third step, conduct a brainstorming session in each category to identify all potential causes of the problem. These causes branch off from its appropriate category, and a certain cause may be applied in several places if they relate to several categories. You can keep asking why each cause happens to generate deeper causal relationships, and eventually, trace back the root cause of the problem. This is also known as the 5 whys technique, used in tandem with the fishbone diagram. Once you have created the fishbone diagram, it can be analyzed to identify critical causes and take decisive actions. You may decide if a potential cause is already resolved or no longer valid, or you can figure out ways how to address each particular cause. Some factors may be controllable, uncontrollable, and some may be experimental, or would need analysis to detect or prevent. Let's have an example. In this hypothetical problem, we are considering the high-performance liquid chromatography, or HPLC analysis of a raw material, and the results varied with greater than the expected standard deviation. So we'll write that problem in the head. Next, we can use the 6M model to get a simplified framework for our categories, then identify all contributing factors. For man, we may consider the training of the analysts, inexperienced ba sila? Also, the communication skills among the personnels. Housekeeping, na ma-maintain ba nila yung cleanliness ng workspace? And of course, the skills sa analytical lab. For materials, the problem may be due to the purity of the reagents, baka contaminated. The grade, baka hindi HPLC grade yung solvent and other chemicals. Storage, baka hindi properly stored and out of date na yung reagents. Sampling, paano kinuha yung materials, saan sila nanggaling or saan sila binili. Next is the methods. The choice of mobile phase is very critical. One should consider the composition, like mixture ba siya ng water, acetonitrile, and methanol, and anong ratios, and ano ang molecular interactions with the stationary phase. What is the pH, and anong buffer ang ginamit to maintain that pH? How strong is that buffer? And the temperature is also important. Paano ang elution, isocratic ba or gradient? Like constant ba ang composition throughout or paiba-iba during the separation process? And dapat kino-consider din yung type of chrome. Normal phase ba siya or reverse phase? Size exclusion or ion exchange? For the sample, how was it prepared? And gaano karaming injection volume, precise ba yung amount na nila-load? And gaano katagal yung sinet na runtime ng separation according to the procedures? Next, measurement. This includes the sensitivity of the detector, the selectivity in separation within the column, and how are the signal peaks in the chromatogram integrated? How did you interpret it and report it? For the machine, it is important to ensure that it is well calibrated, and you may need to inspect every part of the HPLC unit, especially the column since most parameters are dependent on the column. You should check the dimensions, the length, the internal diameter of the column, what is the particle size of the silica spheres, as well as the pore size. Detector, anong type ng detector, UV-vis detector ba or refractive index detectors? For the pump, gaano kalakas yung pressure to pass the liquid through the column? The degasser, effective ba siya in preventing bubbles? And you also have the autosampler, which controls the injection volume and sample. And lastly, for Mother Nature or environmental factors, we have temperature, humidity, and light, which could affect the samples or the whole procedure. Okay, by now, we have a full fishbone diagram showing all possible causes of the problem, and we have organized these factors under each category. As of this stage, you have to personally assess which of these factors or categories would be the most relevant in the scenario, or which is mostly occurring to cause the problem. Of course, you cannot just decide to fix everything at once, because you know that some would not cause greater variability. For a chemical analysis like HPLC, identifying the root cause would be tricky, since most factors would need experimental and statistical methods to determine the extent of effect. But for the other categories like man, which is controllable by management and supervision, and uncontrollable factors like in Mother Nature, these categories can be assessed without experimentation. Now we'll discuss the advantages and disadvantages of using a fishbone diagram. The main advantage of fishbone diagram is that it helps us bring a holistic view of the problem. It serves as a great tool in progressing towards root cause identification. You are now able to focus on the root causes to address a problem rather than its symptoms. Second, it is highly visual and easy to understand. It is one of the easiest tools for organization because of its simplicity, and you can organize it freely. Third, it is applicable to a wide range of problems, from those in manufacturing, marketing, service industries, lab procedures, crime investigations, and even practical scenarios like, why did I get low scores in my exam? Or why is my friend angry with me, and such. Lastly, it facilitates in-depth joint brainstorming discussion, especially if you work in a team. The brainstorming process encourages broad thinking amongst the group, and it prevents you in getting stuck at a problem. On the other hand, the disadvantages include, you may produce irrelevant potential causes that result in confusion and a time drain. From the diagram alone, you cannot really know which cause to prioritize, and you may end up dealing with those that has little impact to the problem. Next, fishbone diagrams can lend themselves to the divergent approach, or the temptation to identify and fix everything that might be causing the problem, which would be a big waste in time and resources. For example, if you have a fishbone diagram with 100 potential causes, you may feel like the problem is too big to handle. Third, complex diagrams with multiple factors can lead to a jumbled mess that is too difficult to represent graphically in a fishbone diagram, making it less unwieldy to use. And lastly, the diagram is based on opinion rather than evidence, and needs testing to prove results. I believe that is all you need to know for the fishbone diagram. Here are my references, but before I end this video, allow me to share a message to reflect on. Life is a perpetual instruction in cause and effect. Dig at the root cause of your problems. Do not dream the leaves.